Yeah. Yeah, you can write in record directly. Determination of partition coefficient. Write down the heading. Determination of partition coefficient of salicylic acid in benzene. Yeah, come. Write down. Determination of heading. Write down. Determination of. Write down. Determination of partition coefficient of acetic acid. Next. Number I don't know. Number I forgot. Number see maybe 8th or 9th.
Only synthesis you have written, ma'am.
Where synthesis you have written?
Fluorescein.
You haven't performed?
No, ma'am.
It's okay. Write down and then you can perform. Okay.
No, ma'am. Up to fluorescein we have written. Next we have kept the heading of next synthesis.
It's okay. Write down that. Leave space. Write down. Okay. You have written the heading synthesis of fluorescence, right? Okay, write down one more experiment. It's okay, you can perform. First write down the experiment. Okay, next experiment. Okay, next. Synthesis of fluorescence is there, na? Synthesis. You have written the procedure? Write one more procedure. Okay, write down next experiment. It's okay. Anyhow, you have to perform. Write down determination of partition coefficient. Write down and then whatever the synthesis you want to perform, you can perform. Okay? It's okay. Write down determination of partition coefficient of acetic acid in chloroform and water. Write down the heading, class. Determination of partition coefficient of acetic acid in chloroform and water. Okay, that is your aim or title. Next, requirement. Requirement, acetic acid, chloroform. Requirement, acetic acid, chloroform, distilled water, acetic acid, chloroform, distilled water, NaOH solution, acetic acid, chloroform, distilled water, NaOH solution, phenolphthalein indicator. Clear? Acetic acid, chloroform, distilled water, NaOH solution, phenolphthalein indicator. Acetic acid, chloroform, distilled water. Maleshwari, first write down, okay? Don't get confused. You can write in notebook also if you don't want to write in record, okay? Write in your notebook and then you can copy when the doubt is clear, okay? Alright, if you had any doubt, you can write in your practical notebook also later on. Okay? Now principle. Now write down the principle. When a solute is distributed, principle, when a solute is distributed between a solvent, when a solute is distributed between a solvent which is immiscible, when a solute is distributed between a solvent which is immiscible, they form two separate layers. They form two separate layers in a contact with each other. They form two separate layers in a contact with each other. The rate of equilibrium concentration. The rate of equilibrium concentration of solute into solvent will be constant. The rate of equilibrium concentration of solute, the rate of equilibrium concentration of solute into solvent will be constant at a given temperature, This they will make if they need. This constant is called as partition coefficient. This constant is called as partition coefficient for that system. Okay. Now write down the procedure. 20 ml of chloroform and 20 ml of acetic acid, 20 ml of chloroform and 20 ml of acetic acid are mixed with 50 ml of distilled water. 20 ml of chloroform and 20 ml of acetic acid are mixed in 20 ml of chloroform and 20 ml of acetic acid dissolve in 50 ml of distilled water. They are mixed in iodine flask. And the solution was shaken vigorously. For 30 minutes. Then solution was transferred. The solution was transferred in a separating funnel. And kept aside to form two different layers. Next point, both aqueous and non-aqueous layer are taken out. Both aqueous and non-aqueous layer are taken out and titrated with 5 molar of NaOH solution by adding phenolphthalein indicator. Okay, so here what you have to do, you have to take 20 ml of chloroform, 20 ml of acetic acid and 50 ml of water. You have to shake and mix that solution properly. And then you have to keep that solution in separating funnel and leave it aside. After some time, 10-20 minutes, you will see that two layers are formed, aqueous layer and non-aqueous layer. Okay, so here next you have to do calculation. Okay, in calculation formula M1V1 is equal to M2V2. So that is the formula, M1V1 is equal to M2V2. So you have to calculate M1 for aqueous as well as M1 for non-aqueous phase. Okay, so here what will be your aqueous phase and what will be your non-aqueous phase? In acetic acid, in chloroform and water, so water will be your aqueous phase and chloroform will be your non-aqueous phase. Clear? So here you have to determine the acetic acid whether it is soluble in water or in the organic phase. Okay, chloroform. So what you have to do, In case of aqueous phase, same formula, M1V1 is equal to M2V2. You have to take 3 reading, okay? Aqueous phase, what you have to do? You have to make 5 molar of NaOH solution and you have to titrate it. Add 2 drops of phenolphthalein indicator in the sample. You have to take 5 ml of the aqueous sample. You have to fill the NaOH in the burette, okay? And then indicator in the aqueous solution 2 drops phenolphthalein. You will see pink color will appear at the end of the reaction. So 5 ml sample and then phenolphthalein indicator and titrate it with NaOH. Okay, you have to take 3 reading and average will be taken. Okay, same thing non-aqueous or chloroform. What you have to do? You have to again take the same 5 ml of sample. Okay, titrate it with 5 molar NaOH with phenolphthalein indicator. Take 3 readings. Okay, clear? This will be your average. So M1V1 is equal to M2V2. So here you have to calculate the M1 part. Okay, M2 is here your volume of sample is here your 5 ml. Okay, molarity 5 molar already it is there. Sorry, it is 5 molar molarity. So 5 multiplied by 5 divided by the average volume. You will get. Okay. So here M1 is the this one mass of your NaOH in case of aqueous. So M2 V2 divided by the V1. V1 is the volume which you consumed. Okay, so that is your reading. M2 is the molarity of NaOH which is constant. 5 molar you are using in the formula. 5 molar multiplied by V2 volume. How much you are taking the volume? Okay, so this is both you will calculate for aqueous and the non-aqueous phase. So now this is the formula. Tell me which experiment was left. Now you have written the procedure. Tell me which experiment was left. You can continue that synthesis. Okay. Which synthesis was left? Benzotriazole is completed already. Wait, I will check.
We have done in our last lab.
Which one?
Diphenyl quinoxaline.
Okay, diphenyl quinoxaline. Okay, you have to synthesize 2,3 diphenyl quinoxaline, right? Okay, last experiment you haven't synthesized. So today you can synthesize. Next time you can do this titration. Okay, that's it. Problem resolved. Okay, now write down, perform the synthesis of quinoxaline. Clear? Give the ma'am required chemicals.